This is MAT 175, Lesson 14, Section 4.6, Complex Zeros, Fundamental Theorem of Algebra. In the last lesson, we learned about zeros, but they were real zeros. Here, they can be complex. Well, what is a complex zero? Complex zero comes from a complex number. Well, what is a complex number? Complex number is real number plus or minus an imaginary number. Together they are a complex number. So we're going to be working with complex numbers in our zeros in this lesson. Okay, so a complex polynomial function with degree n, we look at our leading term to find that degree, has complex numbers, is a non-negative integer, and x is complex variable. It's called a, so we have our a to the and a sub n is a leading coefficient of function f. A complex number r, where we'd have a factor like x minus r as a factor, is a complex zero. So if we were to put in that complex number into our polynomial, we would get 0 out. Alright, every complex polynomial function of a degree greater than 1 has at least one complex zero. So that's what classifies it as a complex polynomial function. It has, if you go to factor it out, it has at least one complex zero in it. Alright, and so we have our complex polynomial function. Now it looks similar to what we did with our polynomial that we worked in the last lesson. We have our factors, x minus r sub 1, x minus r sub 2. I think in the last lesson they used c instead of r1 and r2, but it's the same thing. Okay, so we may find a factor here where there's a complex number in it. And so that would give us a complex zero. Okay, using conjugate pairs theorem, we have a function, f of x is a polynomial whose coefficients are real numbers, but if we have a complex number such as a plus bi, that would be a complex number, is a zero of f. The complex then you're going to have a complex conjugate. And the complex conjugate is if, let's say we had 2 plus 3i. Then the complex conjugate would be 2 minus 3i. So the conjugate is the opposite sign for your middle sign here. Alright, and so if this is a minus b, then the conjugate would be a plus bi. A minus bi, then the conjugate would be a plus bi, and so on. Polynomial f of odd degree with real coefficients has at least one real zero. So if you have a polynomial that has a leading term that's odd, then you know that it has at least one of those factors or zeros is going to be a real number, like 1, 2, it's going to be like an integer, not going to be complex. Okay, here's a real 0, negative 2. But we also have an imaginary, negative 3i, and here we have a complex number. Complex meaning with real and imaginary together as one number. Find the remaining two zeros. So here, the conjugate of a negative 3i would be a positive 3i. There's no real number, so you could say the real number would be 0 minus 3i, but we just drop the 0 and we just say minus 3i. Here 2 plus 4i, so the conjugate, complex conjugate for that would be 2 minus 4i. And so here we have a negative 3i. It follows that 3i is the conjugate of a negative 3i, and 2 minus 4i is the conjugate of a 2 plus 4i, are the two remaining zeros, and that's all you had to do for that one. Polynomial function with specified zeros. Okay, we have a polynomial function f of degree 4. So what does that tell you? Tells you the leading exponent is x to the 4th. So we have how many factors? We have 4 factors. Alright, so here we got 1, 0 is a 1. And we got another 0. That's also a 1. So that would be like saying x minus r1, x minus r2, x minus r sub 3, and so on. So this would be x minus r sub 1. This would be x minus r1, x minus r1. So together they would be x minus r1 quant parentheses squared. And then here we have x minus parentheses 4 plus I, close parentheses. And then you have to have the conjugate to that, which would be what? X minus parentheses 4 minus I. And so the conjugate is 4 minus I. That's also a complex conjugate. Its complex conjugate is also a 0. And so here's this one's x minus r1, right? So that'd be x minus 1. This would be x minus 1 here. So together they would be x minus 1 parentheses squared. So what do you think that graph is going to do at 1? Touch or pass through it? If this is x minus 1 quantity squared, it's going to touch it, right? We know that. Okay, so now this would be x minus r sub 3, x minus r sub 4. So we put the 4 parentheses, 4 plus I. And it's important that you put the parentheses there because eventually you're going to have to distribute that negative. But we're not going to do that yet. We're going to leave them in parentheses for right now. Now notice there's an A out front here. And what is that A going to do to the graph? You should have answered that it's going to vertically stretch it. Alright, and we'll show you how to determine that later on. Okay, so we're just going to leave this A for now. Alright, so now what we're going to do is we're going to FOIL the x minus a, so that would be x squared, and negative 1x, and negative 1x is negative 2x, and negative 1 times negative 1 is plus 1. Okay, and now we're going to take the x times x, and that's x squared. And then we're going to take the x times the minus parentheses 4 minus I, and that's this, minus 4, well, they did this one first, x times 4 plus I, and that's, so it's a minus 4 plus 4, and this will be a minus 4 plus I times x. And then they did x times a minus 4 minus I, and that this will be minus 4 minus I x. And then you have the 4 plus I, negative 4 plus I times the negative 4 minus I. Well, negative times negative is a positive, and so that gives you 4 plus I and 4 minus I. Alright, well, can we combine these two? You should have answered no, because they have to be identical. You cannot combine a 4 plus I with a 4 minus I. Alright, so what we can do now is we can distribute the x inside here. So that'd be 4x plus xi, or ix, and then distribute the negative. So there'd be negative 4x and a negative ix. This would be, again, distribute the x and the negative, and you get negative 4x and a plus ix. And then FOIL this. So 4 times 4, that'd be 16. You get a minus 4i and plus 4i, so the 4i's cancel out. And then I times negative I, and you get a negative I squared. Alright, and so we want to clean this up a little bit, simplify it. So the negative 4x and negative 4x, that'll be minus 8x. Negative ix and a plus ix, they go to 0. Negative ix plus ix, they go to 0. You get a plus 4i and a minus 4i, they go to 0. So they cancel out. And the minus 1i squared, well, I squared is the same thing as a negative 1. So that would be like saying minus a negative 1 there. And so you have a plus 1 and a plus 16, that gives you plus 17. And now what we have to do is FOIL this from here. So this will be x times x is x to the 4th. And then we go, so we're going to distribute the x 1, 2, 3 times. Distribute the negative 2 to each one. 1, 2, 3. And then the 1. 1, 2, 3. And so when we do that, we get x to the fourth minus 10x to the cube plus 34x squared minus 42x plus 17. Okay. Now, this tells you, so back up. This tells you this is x to the fourth, right? So it's going to be positive. So it opens up and to the left, up and to the right. That's what this does. And we already said that at 1 it's going to touch, and there it does. And so we have at most 3, because it's x to the fourth, we have at most how many turning points? Should be 3, right? You take the exponent, leading exponent, subtract 1 from it, so it's 1 turning point, 2 turning points, 3 turning points. And so how do we find out what this A here is? And that's what this last step is. So we pick a point. Now I like to pick 1, but we can't pick 1 because we're trying to determine the vertical stretching, and there is no vertical stretching here, so we can't use 1. Well, we can use 0, right? Now they use 2, but I like 0 better because at 0 you have 0, 17, right? Well, 0 is not, let's see, 0, so x, let's see. If we use 0, x is 0, no, that would make it 0. Can't use 0 either. So they use 2, 3. They picked a point at 2, 3. They looked on, probably on second on table, or they went to trace, found 2, 3. And so they put 2 in for y, and or 3 in for y, and 2 in for x, and divide, solve for a, we get 3 over 37. So that's how they found what a is. So that's what this is. This a would be 3 over 37. So if we were to use the y-intercept like what I wanted to, we would have put 0 in for x, and that would be 0 times a. That doesn't give you, that doesn't help. So we have to use numbers. Okay, move on. Find the complex zeros of a polynomial function and write in factored form. Excuse me. First thing we're going to do is find all possible zeros. So we're going to use the p over q. So this would be 20 over 4. And we're going to make that table. And we need factors of 20, which would be 1 and 20, 2 and 10, 4 and 5. So from that, we can see that we would have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. Alright, so from that we can go ahead and find our first factor by going to our table of values and look at our where y is 0, and that would be one of the zeros. We would see that the degree is a degree of 4, so that's going to open how? Up and to the left, up and to the right. So there will be 4 zeros, and some of them will be complex. So the degree of f is 4, so there will be 4 complex zeros. And here's our potential. I like what they use, the word potential rational zeros. And there's our factors of 20. Since the other one is 1, we won't be dividing, we're just dividing 1 into all of them, so that just makes it all integers. So these are all our potential rational zeros. So we put our equation into our y equals in our calculator, and we look at our table of values and see where y is 0, and that's a 0. Well, if you look in the calculator, you'll see that 2, you'll have 2 0. So we can use that. So we put our coefficients in as our dividend, and then drop the 1 down, and then multiply 2 times 1 is 2. Bring the 2 up. And then positive 2 and positive 2 is a positive 4. Now we multiply 2 times 4, and that's 8. Bring that up to the second row, and 1 plus 8, That's 9 as long as they're the same sign. And then 2 times 9 is 18. Bring that up to the second row. We got a negative 8, a positive 18, so we have to subtract and we get 10. Alright, so now they have 2 times 10 is 20. Bring that up to the second row. We got minus 20 and a positive 20, and that's a remainder of 0. Our remainder of 0 confirms that 2 is a 0. When we have a remainder of 0, then that is a 0. If we don't have a remainder of 0, then this number is not a 0. Okay, so as a factor, we have, this will be x minus r sub 1. Well, 2 is r sub 1, so this will be x minus 2. And then we take the quotient, and that'll be the other half of our factor so far. But we have to go 1 degree less than what we started with. So this is x to the 4th, and now this one will be x to the 3rd. Our quotient will be 1 degree less. So this will be 1x to the 3rd plus 1x squared plus 9x plus 10. And that's what we have here. Now we can do one of two things. We can either do factor by grouping, since there's 4 terms, or we have to divide again. Well, we can't do factor by grouping. It won't, there's no common factors on both sides, so we can't do it. So we have to go back to our table of values and see where there is another 0 for y. And we find that there's a negative 2. So you see, here's our potential zeros. We found positive 2 and negative 2. Alright, now these potential zeros, you could also have the same number repeat. That's possible. But we get a negative 2. So if you only see 1, and you got to divide again, try that same number again. And it's possible it could divide again sometimes. Depends on the polynomial. Okay, so we bring these same numbers here, the quotient, down here. And then we go ahead and use synthetic division again. Drop the 1, multiply negative 2 times 1, negative 2, put it in the second row. Positive 4 and negative 2 is going to give you a positive 2. Multiply negative 2 times 2, bring it up to the second row. That's a negative 4. Not positive 9, negative 4 is a positive 5. Negative 2 times 5, that's negative 10. Bring it up to the second row. Got positive 10 and negative 10 gives you 0. Okay, confirms negative 2 is a 0. So that means you got x minus 2, x minus a negative 2, which makes it an x plus 2, and then we take our quotient. Again, we go 1 degree less, so that's going to make this a 1x squared plus 2x plus 5, and that's what we have here. Now at this point, we want to do one of three things. One is we can see if we can factor, which this cannot factor. Or we can use the quadratic formula or the square root method. Well, we have to use the quadratic formula here. So we go ahead and apply that, set it equals 0, apply it. And so we get x equals to 2, x minus 2 equals 0, x plus 2 equals 0, and then our x squared plus 2x plus 5. Can't factor it, so we have to use the quadratic formula. And so here's our a, b, and c, and our quadratic formula. Well, the problem here is we're going to have a 4 here, right, and a negative 20 here. So we're going to have a negative radicand. And so that's going to come out to be a complex number. And we get negative 1 plus or minus 2i is our complex number. So our zeros are negative 2, positive 2, and negative 1 plus 2i, and negative 1 minus 2i. And so here we have our real zeros here and our complex zeros. And so now we want to put that into one, and so this is what it looks like factored out. And what we did is we put these in as factors. So we already have the x minus 2, that's this, and the x plus 2, that's this. But now this would be x minus r sub 3 and x minus r sub 4. So you have to put minus and then parentheses negative 1 plus 2i. So you're going to have parentheses within parentheses. And then this would be x minus and then negative 1 minus 2i. You have to have the parentheses here. Now, I've seen some textbooks where they distributed this and got x plus 1 minus 2i, and this would be x plus 1 plus 2i. So what they did is distribute it, but this book likes to leave them with the parentheses in there. So you may want to try it in Math Excel to see if you can answer it either way. Okay, and that concludes this lesson.